Hi students, good evening everyone. I hope all are doing well. Welcome to Infinity Learn by Sri Chaitanya. This is me Surya, your chemistry faculty from Infinity Learn. So those who are watching the particular session, just mark your attendance here. So in the last few sessions we have discussed the chapter classification of elements and periodicity properties. So here in this particular session we are going to discuss some JEE based questions based on the chapter classification of elements and periodicity in properties. Okay, I hope you all are watching the recorded session for the chapter. It will be easy for you to give the answer for the questions. Is there anyone watching the session? Just mark your attendance here. Then only I can start the session because it's an interactive session. It will be a question answer type session. So I need your support. So what was the important topic we have studied in this chapter? From the starting of the elements, we have seen the classification of elements, right? We have started from the Dobereiner triads, Newland's law of octaves, Mendeleev's periodic table and Mendeleev's periodic law. Then we have studied about the long form of the periodic table, right? Moseley's periodic classification or the long form of periodic table. And at the second session, we have discussed about the introduction to modern periodic table. We have seen how to predict the position of an element in the periodic table, right? Just like a block, period and group. Then after that, we will be discussing about the second part of the chapter, right? We was discussed about the second part of the chapter, that is periodicity in properties. We have seen atomic radii, ionic radii, ionization enthalpy, electron gain enthalpy, and some of the properties, right? Some of the properties, how they are affecting in a group as well as the period. Then the last class we have discussed about the diagonal relationship, right? In the case of second period elements, they are showing some difference in their properties due to small size and electronegativity. So far we have discussed the complete chapter. Now let us practice some questions based on the topic. So here is our first question. An element has electronic configuration 1s2, 2s2, 2p6, 3s2 and 3p3. Predict the period of the element belongs to. So in the session we have discussed about how to predict the position of an element, right? If you are not aware about the electronic configuration of an element, from the idea we will be getting the idea about the block of that element, period of the element as well as the group of that element. So you need to concentrate on the electronic configuration of this element which is given here. So this will be the electronic configuration, right? 1s2, 2s2, 2p6, 3s2 and 3p3. Here you need to identify the maximum number here. It will be 3 here. That belongs to our period of that element. So option A will be the correct answer. Period is equal to 3. From the same data, we can identify the block of this element, right? In which the last electron is entering into the p subshell. So this will be considered as a p block element. Now, how we can predict the group of this element? If it is a p block element, we need to identify the last number of electrons present in the p subshell, then add 12 over that, right? So it will be 12 plus 3, that is equal to 15 group element. Okay, now we are moving to our second question. The correct arrangement of oxygen, phosphorus and nitrogen in order of increasing their radii. So we have discussed in the periodic classification of elements and the properties. We have seen the atomic radii and ionic radii, right? So as we already know what is the trend of atomic radii or ionic radii in a group. So you need to identify what about the range of this oxygen, phosphorus and nitrogen. So here is the order of these elements, right? Nitrogen and oxygen belongs to the same period in which they are moving from left to right in a period. So what is happening to the radii if we are moving from left to right in a period? Whether it is increasing or decreasing? Size is decreasing, right? Size is decreasing, which means that nitrogen is having higher size than the oxygen as compared to nitrogen and oxygen in the same period. Now, if you are focusing about the nitrogen and phosphorus, they are belong to the same group, right? If you are moving from top to bottom in a group or down the group, what is happening to the size? Size increases, right? So we can say that phosphorus is having the maximum size as compared to the nitrogen. So our order will be phosphorus is having higher, then nitrogen, then oxygen. Or we can write it as oxygen less than nitrogen less than phosphorus. According to our option, option A will be the correct answer. So in order to answer these type of questions, you must have idea about the trend of ionic radii or atomic radii in a group as well as a period. So from the elements, you need to identify the atomic number, then identify whether it is moving from top to bottom in a group or left to right in a period. Then discuss with the atomic size trend. Now we are moving to the next question. The covalent bond length of chlorine molecule is 1.98 angstrom. What is the covalent radius of the molecule? So while discussing about the atomic radii or the atomic size, we have discussed three different types of radii, right? Covalent radii, metallic radii and van der Waals radii. So from the data, you need to get an idea about what is the relation between covalent bond length as well as the covalent radii. So what will be the answer for this question? Okay, in the case of here, chlorine molecule is formed by the sharing of electron, right? Because it is covalent molecule. So in the case of chlorine molecule, the covalent bond length is given as 1.98 angstrom. So from the data, we can identify that the covalent radius of the single atom will be equal to half of the bond length, right? Half of the bond length. So if I am taking the covalent radii or radius of the chlorine, it will be 1/98/2. That is equal to 0.99 angstrom. So option D will be the correct answer. Is the question is clear? So in the concept class, I have already given the idea about the covalent radius, right? Covalent radius. In the ionic radii, we have seen three different types of radius. One is covalent radii, and the other one is van der Waals radii, and the other one is the metallic radii, right? So in the case of covalent radii, it is equal to the half of the covalent bond length. So from the data, it is given covalent bond length is 1.98 angstrom for the chlorine molecule. So we need to identify the covalent radii of the single chlorine atom present on it, right? So it will be the half of the value. 1.98 by 2 is equal to 0.99 angstrom. Okay, I hope you understand. Now we are moving to the next question. So read the question carefully. The IUPAC symbol for the element with atomic number 119 would be. So in the classification of elements, we have seen the nomenclature of the elements, right? If you are having the element having atomic number greater than 100, there will be some of the rules, right? There will be some of the rules to find out the name of this element, right? If you are having the atomic number. So here the atomic number is given 119, right? 119. So these are the 3 digits. So correspond to each digit, there will be some of the word root, right? So if I am taking digit 1, it will be corresponds to the word root of un, right? Then in the case of 9, it will be n, right? So what we need to do here, we need to identify the name of this compound. 1 stands for UN, right? So first letter will be UN. Then again 1, which means again UN. Then for 9, it will be ENN. This is a word root. Those who are missed the session, just revise the session. Then the suffix will be IUM. This is the IUPAC name of this compound with atomic number 119. And the symbol for this compound will be the first letter U, then again U, then E. U will be the correct answer here, which means option A will be the correct answer. Okay, I hope you understand how to write down the IUPAC naming of the element which is having the atomic number greater than 100. Depending upon the word root or the names, you can just give the IUPAC name of this compound like this. In the IUPAC name, the last suffix will be IUM only, depending on the numbers. Here is the next question. Which of the following iron has smaller size? Options are given here: Cl minus, S2 minus, K plus and Ca2 plus. So while discussing about the atomic radii, we have seen the ionic radii also. There will be cationic radii as well as the anionic radii, right? So based on that idea, you need to answer this question. Which one of the following has the smallest size or small ionic radii? So here option D will be the correct answer, that is Ca2 plus, right? So as we already know, if you are comparing the sizes of neutral atom as well as the cation as well as the anion, it will be having Okay, this will be the radii of cationic as well as neutral atom as well as the anionic radii, right? So here we need to consider the anions given here. If I am comparing the Cl minus and S2 minus, they will be having the more size as compared to the cations, right? So if I am asking about these two ions, S2 minus will be having the more size because of the greater negative charge, right? Greater negative charge on the anion. So it will be having the more size. Here we need to identify the one which is having the smaller size. As we are comparing anion as well as the cation, cation will be having the smaller size, right? Then how we can predict the cation with high positive charge, right? If I am comparing K plus and Ca2 plus. So what you are observing here, in the case of K plus, one electron is removing. But in the case of Ca2 plus, two electrons are removing, which means that there will be strong attraction between the electron as well as the nucleus. So there will be having the smallest size. So we can simply say that the cation with higher positive charge will be having the smaller size and the anion with higher negative charge will be having the highest size. Okay, I hope you understand. Here is our next question. Based on the complete summary of the periodic properties, read the question carefully. In general, the properties that decrease and increase down a group respectively are decrease down a group and increase down a group. Okay, what will be the general trend of atomic radii along a group, down a group? Okay, these are the four important properties we have discussed, right? Atomic radii, ionization enthalpy, electron gain enthalpy, and the electron negativity, right? So down the group, what is happening to the atomic size or atomic radii, it is increases, right? Down the group, if you are moving from top to bottom in a group. So generally, it will be having the decreases value for these three parameters or these three properties, right? Ionization enthalpy, electron gain enthalpy, and electron negativity decreases down a group. So what will be the correct answer for this question? So it will be option C, right? Electron negativity is decreases down a group and atomic radius increase down a group. So option C will be our correct answer. Okay, I hope you understand. Now we are moving to our next question. The same type of question we have already discussed in the previous question. The ionic radii in angstrom of N3 minus, O2 minus and F minus are respectively. So here it is asking about the case of anionic radii, right? Because all the ions are given as the anions, negatively charged ions, because it is anion. So you need to identify the ionic radii, the order of correct order of the ionic radii for these particular ions given here. So as we already know, anionic radii will be higher, right? So if the charge on, anionic charge is higher means Okay, I hope you understand the point, right? If you are taking the three different anions, you will be having the one which is having the maximum size will be having the more negative charge. So if I am comparing here, it will be N3 minus, right? N3 minus, there will be 3 negative charge. Then O2 minus, then F minus, right? 2 minus and F minus. So you need to identify the value given in the data, and it is clear that there will be values between 1.71, 1.40 and 1.36. You need to identify the correct order here, right? So in the case of N3 minus, that will be maximum value in between these data. So it will be 1.71, right? 1.71. The next one, we need to compare with 1.40 and 1.36, right? O2 minus is having the size higher than the F minus, so it will be 1.40, and the last one it will be 1.36, which means option A will be the correct answer here. Okay, the main point you have to keep in mind that in the case of anionic radii, generally anion will be having the more size as compared to the cation, and if you are having the more negative charge on the anion, they will be having the higher size. Let's say they are having the, here in the case of N3 minus, it will be having the maximum size of 1.71 angstrom as compared to O2 minus and F minus. Okay, here is the next question. Among the following elements whose electronic configuration are given, the one which is having the highest first ionization energy, already electronic configuration is given. So ionization enthalpy or ionization energy we have already seen in the concept classes. So what do we mean by the ionization energy? If we want to remove the last electron from the shell, right, we need to give some energy for that. That energy is commonly known as the ionization energy. So from here, we need to identify the one which is having the stable valence shell electronic configuration, right? So if I am comparing here, you can say that in the case of second option, right, 3p3. 3p3 means it is a half-filled orbital, right? Half-filled orbital means it will be more stable. So if you want to remove one electron from the 3p3 orbital, we need to give more energy, right? We need to give more energy so that its ionization energy will be maximum. So option B will be the correct answer here. Okay, if you are getting this type of question, you need to consider about the half-filled or completely filled orbital, right? Half-filled or completely filled orbital. Here in the case of P, it is P3. P3 means half-filled orbital, that will be more stable. If you want to remove one electron from the 3p3 orbital, it is very difficult to remove, right? Because it is a stable configuration. We need to require more energy to remove those electrons. That is why these molecule is having the highest ionization enthalpy or highest ionization energy. Here is the next question. Electronic configuration is already given. The list 1 it is given the electronic configuration. The list 2 it is given the particular element, whether it is a D block element, halogen, alkali metal or noble gas. So try to find the answer for this question. So while discussing about the prediction of block or period or group of the element, I have already discussed about the identification of block, right? Identification of block from the electronic configuration. So from the electronic configuration, you can identify whether it belongs to the D block element or it is a halogen or an alkali metal or a noble gas. So in order to answer this question, you must have a clear idea about the periodic table. So what will be the answer? Okay, those who are watching this session, just give me random guesses also. We have 4 options here, right? You can just give me A, B, C or D. So option B will be the correct answer here. So how we can solve this question? So if I am considering this element, right, this configuration, so from this you can identify that this is a S block element, right, because last electron is entering into the S subshell. So this is an S block element. Now how we can predict the group of this element? In the case of S block element, if we want to predict the group of that element, we need to consider the number of electron on the S orbital, right? So here, in the case of S orbital, there is only one electron. So this will be the first group element. The first group element is commonly known as the alkali metal, right? Alkali metal. So A will goes with the 3. Is that clear? Yes, option B is the correct answer. Now what about the second element? Element B here, right? 1s2, 2s2, 2p6, 3s2, 3p6. What is the block of this element? You need to consider only the outer electron here, right? Outer electron is entering into the p subshell, so it will be the p block element, right? It will be a p block element. Now how we can predict the group of this element in the case of p block element? Okay, just consider the number of electrons in the p subshell, then add 12 over that, right? So it will be 12 plus 6, that is equal to group 18 element. Group 18 element are commonly known as the noble gas, right? So B will goes with 4. Now what about the case of element C? Okay, which point I want to explain again? From the electronic configuration of any of the element, we can just predict the position of that element, right? From the block, from the electronic configuration, we can find out the block, period as well as the group. So, for example, if I am taking the first element, right? First element, you need to consider only the outer electronic configuration. Here it is 4s1, right? 4s1, which means that the last electron is entering into the S subshell. So, we can predict the block of those elements are in which the last electron is entering into which subshell. If it is entering into the S subshell, it will be S block element. If it is entering into P subshell, it will be P block and so on, right? There will be S block, P block and D block and F block elements are present in the periodic table, right? Here it will be S block element. So in the case of S block element, how we can predict the group of that element? So in the periodic table, we have already seen there will be only 2 group elements, like group 1 and group 2 elements are commonly known as the S block element. So group number will be either 1 or 2 here. So here the last electron is 1 only, so it will be the first group element. And the first group element is commonly known as the alkali metals. Okay, I hope you understand. And in the case of group B, right, element B, right, what you are observing here in the case of element B, the last electron is entering in the P subshell, right, P6 electron, last electron is entering in the P subshell. So it will be a P block element, right, it will be a P block element. Now if you want to find out the group of P block element, we need to consider the number of electrons on P subshell. Then add number 12 here, you will get the group number. So what will be the group number of this element? Number of electron in the p subshell is 6 here. I am adding 12. 12 plus 16 is equal to 18. So group 18 elements are commonly known as the noble gases. Clear? Okay. What about the cases? Third element C. So here you need to focus on the point that if you are observing the last electron is entering the 4s orbital also, according to our principle, there will be last electron is entering into the 3d subshell. Before entering into the 4s, it will be moving to the 3d subshell, right? So here the last electron is entering into the d subshell, so it will be a d block element. Now, how we can predict the group number of a d block element? For a d block element, you need to add the total number of electrons on the s orbital as well as the d orbital. So here it will be 6 plus 2, it will be a group 8 element, right? 6 plus 2, it will be group 8 element. So as we already know in the case of transition element, group 3 to 12 are known as the d block elements or the transition elements. So it will be belong to the group 8. Then what about the last element? 1s2, 2s2, 2p5. Which block it is? Consider only outer electron. Okay, it is 2p5, right? Which means last electron is entering the p subshell. So this is again a p block element. Now, what about the case of group number in the case of p block element? Add the number of electrons in this p subshell plus 12. So here it is 5. 5 plus 12 means it is group 17 element, right? Group 17 element is commonly known as the halogen. Clear? So D will go with the 2. So option B will be our correct answer. Okay, I hope you understand. Now we are moving to our next question. Read the question carefully. In the long form of the periodic table, the valential electronic configuration is given as 5s2 5p4, which corresponds to the element present in. We need to identify the group number as well as the period number of this element having the outer electronic configuration is 5s2 5p4. So what will be the answer? Okay, directly the outer electronic configuration is given here 5s2 5p4. We need to identify the block, group and period. So again the last electron is entering the p subshell, right? So this is the p block element. So for the p block element we can predict the group number as number of electrons on the p subshell, that is 4 here plus 12, that is equal to 16. So this is a group 16 element, right? Group 16 element. Now how we can predict the period number? Here the number of subshell, right? Here 5s2 5p4, which means the maximum number of subshell, I mean maximum number of n value here is 5. So period is equal to 5 here. Which means option C will be the correct answer, group 16 and period 5. Okay, I hope you understand. Now moving to the next question. Again ionic radii. The correct order of radii is, read the question carefully, there will be multiple answers. The correct order for the radii. So option B and D are the correct answers, right? Option B and D are the correct answers. So if you are comparing the size of lithium, sodium and potassium, what is the specialty here? The case of lithium and sodium and potassium. So they are belong to the same group, right? So as we already know, if you are moving from top to bottom in a group or down the group, what is happening to the size? Size increases, which means that potassium is having the maximum size than sodium than the lithium, right? So this will be the correct order for the atomic radii for lithium, sodium and potassium. So option B will be the correct order. Then what about the case of option D? Beryllium, boron and nitrogen, right? Beryllium, boron and nitrogen belongs to the same period. So what is happening to the size when we are moving from left to right in a period? Beryllium to nitrogen, size decreases, right? Size decreases, which means that beryllium is having the maximum, then boron, then nitrogen, right? So this will be the correct order, which is given in the option D. Now what about the case of option A and C? Why it is incorrect? In the case of anion, as we already know, whenever the charge on the anion increases, there will be having the higher size. So this will be the reverse order. N3 minus will be having higher charge and higher size, then O2 minus, then F minus. So this is the reverse order. And in the case of cationic size, right? Cationic size means whenever the charge on the cation increases, size decreases. Again, this is also the reverse order. Fe2 plus is having less, Fe2 plus is having the less value, then Fe3 plus, then Fe4 plus, right? Okay, I hope you understand. Now we are moving to our next question. This is an assertion reason type question based on the ionization enthalpy concept. You need to identify whether the assertion and reason are true or false and if it is the correct explanation or not. So option C is the correct answer. Both assertion and reason are true and R is the correct explanation of A, right? So if you are asking about the ionization enthalpy, in the case of ionization enthalpy, we have seen the two types of ionization enthalpy, right? First ionization enthalpy and the second ionization enthalpy. For example, if I am taking Mg, right? Magnesium is having the atomic number of 12. So it is 1s2, 2s2, 2p6, 3s2, right? If I am removing one electron from the 3s orbital, I will be getting the Mg plus ion, right? Mg plus ion by losing one electron. This energy required is known as the ionization enthalpy. First ionization enthalpy represented by IE1, right? IE1, which is easy to remove this one electron, right? Remove this one electron. If I want to remove this complete complete 2 electron from the 3s orbital, I need less energy, right? That is why given here, the energy required to form Mg2 plus from Mg. Mg2 plus from Mg is very difficult because we need more energy than the Mg plus from Mg, right? I hope you are understanding the question. So in the case of magnesium, this is the electronic configuration 1s2, 2s2, 2p6 and 3s2, right? If you want to remove the 2 electrons from the 3s orbital, because it is completely filled, right? Completely filled means there will be stable electronic configuration. If you want to remove these 2 electrons, you need more ionization energy, right? That is given in the first sentence. The energy required to form Mg2 plus from Mg is much higher than Mg plus from Mg, right? If you want to remove only one electron, it will be very easy. Okay, I hope you understand. So this assertion is true here. Then what is the reason behind that? Mg2 plus is small ion and carry more charge than the Mg plus. So this is also true because this is the correct explanation. So option C will be the correct answer for this question. Here is our next question. You need to identify the IUPAC name of this compound, and there is no any atomic number given. You need to identify the atomic number from the electronic configuration given here. It is radon 5F14 6D1 7S2. First identify the atomic number of this element. Obviously it will be higher than 100, then only we can find out the IUPAC name of this compound. So from the digit you will get the idea about the word root. So what will be the atomic number of this compound? So radon is having the atomic number of 86, right? So 86 plus 14 electron is present in the 5f orbital. Then 1 electron in the 6d orbital. Again 2 electron in the 7s orbital. So total it will be 103, right? 103 will be the atomic number of this particular element. Now what will be the word root stands for these 3 digits? If I am taking 1, it will be un, right? If I am taking 0, it will be nil. Then if I am taking the 3, it will be tri. Then after the name of this compound, you need to add IUM, right? So this will be the IUPAC name of this compound, unyl trium, having the symbol of UNT. So option D will be the correct answer here. Okay, now we are moving to our next question. The last class we have discussed about the nature of oxides, right? So you need to identify the nature of the oxide given in the list 1 with their character in the list 2. So as we already know, the metal oxides are forming the basic oxides and non-metal oxides are forming the acidic oxides, right? So here in the case of Cl2O7, chlorine is a non-metal, so it will be forming an acidic oxide. So A will go with 4 here. Then what about the case of Na2O? Na2O, which means sodium, right? Sodium is a metal here. So it will be forming a basic oxide. So we will go with 2 here. What about the case of Al2O3? In between the periodic table, in the center of the periodic table, they will be forming generally amphoteric oxides, right? They are having the characteristic as well as like acid as well as base, right? So Al2O3 is forming the amphoteric oxide. Then N2 is the common example for the neutral oxide here. So D will go with 3, which means option B will be the correct answer here. Okay, I hope you understand. Here is our next question. The general electronic configuration N-1 D3 NS2 indicates that this element belongs to which group? N-1 D3 NS2. This is the general electronic configuration of a D block element, right? D block element, because the last electron is entering into the D subshell here. So as we already know, if you want to find out the group number of a D block element, you need to add the total number of electrons present in the N-1 D subshell as well as the NS electrons, right? So that will be equal to here, it is 3 plus 2, which means it is a group 5 element. So option A will be the correct answer here. Okay, these are the important questions from the classification of elements of periodicity and properties. I hope you understand. If you have any doubt, you can ask. So we have successfully completed our chapter classification of elements and periodicity and properties. In that chapter, you need to focus on mainly how to predict the position of an element, to find out the block, period, as well as the group of that element. And the second one, you need to identify the IUPAC name of any of the compound which is having the atomic number greater than 100. There will be specific rules to find out the name of that compound. Just give a reminder over that. Then next one, periodic properties, right? What is the range of, what is the trend in the case of group as well as period of the atomic radii, ionic radii, ionization enthalpy, electron gain enthalpy, and the electron negativity trend. Then the last one, it is about the diagonal relationship. These are the main important topics which we have covered in the chapter classification of elements and periodicity and properties. Okay, I hope you guys enjoyed the session. If you really like the session, hit the like button, share this session to your friends also, and subscribe our channel. If you want to get the session PDF, you need to join our Telegram channel, Infinity Learn 9 and 10 Telegram channel. You will be getting the session PDF after all the classes there. Okay, I think we can wind up the session for today. So thank you so much all of you. See you in the next class. Bye-bye.
ఏదో ఒక దూరంలో ఉన్న అలా చూస్తూ కూడా కనిపిస్తలేదు.